Okay, so we're going to be looking at numbers. So what I want, our objective, okay, is to understand that numbers can be written in different bases, and then you are going to also be able to write in binary form. Yeah, so this binary, you will recognize it's very well used. You probably will recognize it from films and things like computers use, well, maybe used to use binary form, but it's
it rings a bell, I know what it is, but I forgot the meaning.
Yeah? You might recognize binary as being all ones and zeros. Okay, now just to explain this basis. Now, currently, you probably have only ever worked in number base 10, which is a nice, easy one to do because 10 is a nice number to work with. And what do we mean by base 10? Well, base 10 is when, to make all the numbers that you are going to use, you use 10 digits. The first digit is 0, then it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you'll notice base 10 does not have a 10. Okay? It has 10 digits, the first one being 0.
Yeah. Is it because the 0 and the 1 have already been used?
So yeah, that's the thing. So when you count things, when number started, what they did was they started with, well, what symbol can I use when I don't have anything? But actually, that's a big number, 0, coming in. They actually started with, what symbol can I use if I have 1 sheep? So they put a line for 1. The Romans did what for 2 sheep?
2 lines.
2 lines. 3 sheep?
3 lines.
3 lines. 4 sheep? A 1 and a V.
Yeah, I don't know the
Yeah,
Roman.
and the 5 was a V. But actually, it was quite. It was great for counting, but not very good for maths. And it was actually in the Middle East, like the Persian Empire and Indians, and they came up with a different set of symbols. And actually, they introduced 0. It was only with the 0 that we could then do maths as we know it. So they came up with these similar to these. If you look back in historical stuff, they're not quite, but they're similar. So they had 10 symbols that counted 10 things. But then they were like, well, what happens if I have another sheep? So I have what we call 11 sheep. Do I make a new symbol or what?
You use the numbers that are there, you put 2.
Yeah, so we go back to the beginning and we choose, well, if I want another symbol, I take 2 of them together and I have, well, I've now got 1, 10, no use. So that's the next one. So you're using those 2 symbols. And then the next one is that one and that one on together. And then it's 1 and 2. And then 1 and 3. And 1 and so on. Right? Yeah. Once we've got all the way up to 1, 9, which we call 19, we then do
2, 0, 2, 1,
2, 0, 2, 1, and so on. Yeah?
Mm-hmm.
And that goes all the way up. Not yet, don't write it yet. That goes all the way up to 9, 9.
Yeah.
But then what happens?
Yeah, 1.
And then it goes back to the 1, 0. But then we go for another 0. And that's where our 100 comes in.
Yeah, that's cool.
Yeah? So that's number base 10. Right, so we've got 10 digits. Make sense? So that's how people then did it. That was a very structured. Now, if you were doing Roman numerals, it's just awful trying to write big numbers. Yeah. Awful. It's like, so this is a much nicer way of doing it. Much nicer. Yeah, exactly. Do you know how to write like 2000, like the year? You ever seen on the film credits the year 2015? It's like la la la
Yeah.
X la C. Right, you know, C stands for 100 and so on.
Oh,
Difficult. Okay. Do you want to write that down then?
Yeah.
Give you a chance. So base 10, nice and easy. It's what we always use. And we use that because it's easy to do our maths. However, we don't have to use base 10. We could use a different base. So for instance, if I asked you to write down the first, let's say 10, if I were to count 10 sheep, so I know I've got 10 sheep, how would you write that I've got 10 sheep if we were using base 4? Well, have a think about it, compare what base 10 meant, see whether you can write the digits down that I'm allowed to use for base 4, and see whether you can write down the mark I would put on the piece of paper to tell someone I have 10 sheep, but if I'm using base 4, not base 10. Make sense to you?
No, but wouldn't that be easy because 0 and 1 are always the first numbers?
Yeah.
You could just do 1 and 0. But I don't understand that.
No? Well, let me do this one for you, and maybe I can give you a different one. Base 4 means we only use 0, 1, 2,
Up to 4, yeah.
3. Base
Oh,
10.
yeah, because they're 0. Yeah,
Yeah.
sure.
So, 0 is fine, but I can only count to 3 sheep now. So what's a 4? How do I write I've got 4 sheep?
10. Because that's
Well,
the next
it's not called 10.
It's called
It's
fifth
1,
number.
0. It's 4, isn't it? That's 4, but written 1, 0. What is 5?
They're written 1, 1.
Yeah, good. And 6?
They're written 1, 2.
7?
1,
8?
Oh yeah, 10, 2, 1. I know
9?
2.
10?
2, 2.
So
Okay.
10 is actually written like that. This is not
Wow.
22.
It's 10.
It's 10.
So this could also be used as sign language, actually.
Yeah.
Oh, that's cool. Oh, that's cool.
I've done it with my year 12s where I change the number base and give them a sum like it's written 1, 0 plus 1, 3. And I say, what's the answer? And they write 23. But it's not, because it might be in base 4, for instance, not
Yeah,
base 10.
but it is quite
So this
confusing.
number is not
22.
not 22. So I'm going to write in words, not 22, that is 10. Because obviously that's a different way of writing. This is the now in base 4, the mark I make for 10. Now can you, like you've already said, how complicated is that?
Really complicated.
And that's what people that are starting maths think about base 10. Because this is the first time you've seen base 4, so everything's difficult. Yeah? I could give you a really simple sum now. Okay? So for instance, just to show you how difficult things are, if I said to you, what is 3 plus see, you want to say 14,
No,
but it's not.
It's 3 plus. Wait, 3 plus 5?
Yeah,
It's 3 plus 5.
which is
What? No, because 11 is 5. It's 8.
right. So the answer is it's 3 plus 5 is 8. How do I write 8?
Is there, oh, 1, 3.
Yeah, sure. I'm at 11. It's not 11, it's 1, 1. Plus 1, plus 2, plus...
2, 0. This is so confusing.
I know it is, isn't it?
10 is, oh my gosh. 11 is 5, 6, 7 is 4.
See, if I were to put it in base 10, just to maybe help you understand, although maybe it won't, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this, I would say, if I was reading base 10, it would be 3 plus 11 makes 20, which is wrong. But in base 4, it's 3 plus 5 makes 8. But different symbols. So it's just like changing. It's like going from English to French.
Yeah.
Well, it's not with numbers because they're the same. But well, it's like going from English to Arabic. Completely different symbols, for instance. Yeah. Okay. Here's one then. I'm going to ask you to write down numbers. I'm going to ask you to write down the first 5 numbers. First 5 numbers in base 2. Base 2. First 5 numbers in base. So if I ask you for the first 5 numbers, if I was going to do base 10, it's 0, 1, 2, 3, 4, 5. But we're not in base 10, we're in base 2. So it's 0, 1,
10, 1,
1, 0.
But why does
1, 1.
1,
Oh, yeah,
1,
1, 1,
1, 0, 0.
Yeah, 1, 0, 0.
1, 0, 0.
Then 1, 1, 1.
No, what's about 5 then?
1, 0, 1.
Oh, yeah, and that's everything. Yeah.
What would 6 be?
Oh, 6 would be 1. Wait, 1, 2, 3, 4, 5. That would be 1, 0. No, 1, 1, 0.
Yeah, good. 1, 1, 0. 7 would be
1, 1, 1.
1, 1, yeah. And
It
then,
is
Eight.
very
then
confusing.
if we go 1, 0, 0, 0.
good. Millie's got this cracked. Yeah?
You have to think a lot about it. You can't just do it this like in a hurry.
You have to think. Now, because it's almost lunchtime.
No. Oh, we haven't had lunch.
No. This has a name. What do you think base 2 is called?
Base 1.
8.
Look at your objective.
Binary.
This is
Binary
binary.
form.
Now the thing is, binary has been very useful for computers because if we can write numbers as a series of 1s and 0s, basically 1s and 0s to a computer mean on or off. Right? There is no on, off, half on, off. So you can't have a 0, 1 and a 2. So a computer works with on and off. Alright? So if you want to write something using lights, okay, how would you get a very simple computer to write the number 8? So how many lights do you need?
1,000. 10. 2. 4.
4. And how would I show the number 8 using 4 lights? How? If you think 1 means switch it on, 0 means leave it switched off. So if I have 4 lights, I switch the first one on, I leave the next 4 switched off, that means 8 to a computer. And that's why binary was used for computers
But
to
is
start.
that how computers also work nowadays? With binary?
It's much, much more complicated, but we also have different ones. But yeah. Anyway, we'll carry this on next time, lunchtime.